Hello, everyone. First of all, I'm going to say that I'm very sorry not to be with you today. Physically, it was a hard decision to make, but I feel safer this way. So I'm going to start with my presentation. Well, I'm going to skip the reminder of goals because I think they're pretty clear. This is stage. And here is my Gantt chart. What is important about my Gantt chart is that a second study was canceled in the last 6 months, which forced me to an application of an extension of contract for 4 months, which was luckily accepted last summer, and that I'm going to basically use at the end of my PhD to write the thesis. Meanwhile, I'm currently conducting my last study, and I will talk about it. But first things first, as I already mentioned in the last network-wide event, I finished in April the study number 2, which was a pilot study with 2 undergraduate students from PU level. And after that, I had the opportunity to analyze qualitatively, to make a qualitative thematic analysis of the level that they created. Okay, so I analyzed the different, basically, mainly the game items. And for that, I used Atlas TI to code the game items that appeared in the level. With that coding, I identify a pattern. So basically, this is the pattern that I identify, and it is that the level was used as a communication channel where the creators were using both existing game items and new game items. And what was interesting was that in the new game items, they use chemical equipment, but also chemical and physical phenomena. So like fire, ice, and these elements. Both the equipment and the chemical and physical phenomena, they were assigned a positive, a negative, or a neutral effect or impact in the gameplay through the interaction that they were assigned. So for example, in the level that we can see here in the picture, we can see that the fire are interacting as coins, and this has a positive feedback in the gameplay because the avatar, when it gets in touch with fire, the player receives a coin. And then the ice on the other side is interacting as spikes, which means that has a negative impact in the gameplay. And by doing so, the creators were communicating that at that point of the chemical process, there was an interest to increase the temperature in order for the reaction to happen. So that's why the fire, it has a positive impact, and the ice a negative one, which was very useful for me to create a correlation between flowcharts and more precisely about process flow diagrams that are generated by the simulators, mainly used in chemical engineering, and concept maps. And this is interesting because concept mapping is an existing methodology that is already benefiting teaching and higher education, from which I got inspired. And I used Rousseau's and Wilkinson's framework to assess concept mapping activities to create an assessment framework. The assessment, as you can see in this daisy-like figure here in the slide, consists of 6 different categories. So we have accuracy, that has to do whether the content that is included in the level is correct or not. Utility, that has to do with whether the content that appears is realistic of a real chemical process. Then clarity, it has to do not only that the content is clear, but also the structure, how it's structured in the game level. Complex, whether the level also reflects the complexity that usually involves chemical engineering processes. Logic of organization, the category organization, that it's refers to the logic flow and relationships of equipment and also the different elements that appear in the level. And finally, if the content is somehow represented in a creative way. And together with this assessment framework, there is a scale, an assessment scale. So it goes, there are 4 different grades. So basically, if we can say that the content is completely correct and there are no mistakes in a level, we can give it a 3. So to say that it has been, that the category accuracy of that level has been achieved. But if on the other side, it's correct, but there are some limitations, then we give a 2, if it meets revision a 1, and if it's not included, then a 0. This kind of scale, it's very interesting because it can help to design the winner of the game jam. So basically the team with the highest score, it's going to be designed as the winner of the activity. But there is also another purpose of this assessment framework, and it is that it can be used as a kind of guidelines at the beginning of the activity so that teams know how they are going to be evaluated. All this information also helped me to publish a paper and to create the game jam as an activity linked to a process design course of chemical engineering. So the learning experience could be actually divided into 4 different stages based on Kai's ICAP model. The ICAP model of Kai's refers to the behaviors of learners. So for example, if learners are in the game jam, and the first stage, it's defined as passive and active because participants, they go from a passive state to an active one. In this stage, it's where they learn new knowledge, and they basically learn about, they participate in a game level design lecture, but they also get familiar with the game editor. In the second phase, it's a phase where they are active and interactive, and it's where they practice prior knowledge, because it's when they create the process flow diagram with the simulator. It's the process flow diagram that will be linked to the game jam, to the level. In the third stage, it's called active, interactive, and constructive, and it's where new and prior knowledge is combined. And this is so because it's when participants create the new game items and also the levels itself. And finally, there is this active and interactive learning activity that actually concerns that fosters, let's say, learning transfer, because it's when the participants present the levels that they have created. So I'm currently conducting study 3. So basically, the game jam has been integrated in a process design course at the Technical University of Denmark, DTU, and it has been divided into introduction lecture that took place in September, and into 2 different sessions. Session 1 took place last Saturday, if you're watching this on Monday. And it's during the first session, participants were creating the levels. And then in the second session, that it's going to take place this week, if you're watching this on Monday. And during the second session, participants are going to present the levels, and the winner, it's going to be a design as well. So during the introduction lecture in September, I presented students with part of a level example, where I also provided them with the game design lecture, and they were also introduced to the GEL, the game editor for learning. So basically, the example that I provided was based on an activity that was presented on a final project, because in this process design course, students have to present different projects, and the CameJam is closely related to the final project, where they have to present a full report, including a process flow diagram of cumin production. So what I did, it was to take an example of cumin production of the previous year. And then in this example, as you can see here in the slide, there are 4 different stages: pre-treatment, cumin production, downstream process 1, and downstream process 2. So the level is supposed to reflect the whole process, but the example that I provided was just part of the level, and it was based on the pre-treatment. Okay, so basically there is only, this is the level that I presented, and basically there is only a pre-cooler on the top which is missing, but all the other elements are there in my level example. So what we can see here in the level example is that there are in blue on the top is 1 reactant, benzene, and on the bottom there is another reactant, propylene. There are 2 mixer tanks, and because on the top, the one on the top in blue, it has to, benzene is recycled and reutilized. That's why the stream flow is pointing on the left, okay? Then there are 2 centrifugal pumps, another mixer where we mix the 2 reactants, and then we have a vaporizer flash tank, a tubular eye preheater, and finally a plug flow reactor. Okay, now here in this example, for example, and there are some mistakes. And for example, if we base the assessment on the assessment framework that I showed you, I wouldn't get all the points, okay? So it's just for inspiration for students, because some of the equipment, it's not correct. And also, for example, it wouldn't be, I will be penalized for realism, because the size of the equipments are not very realistic either. Well, anyway, so this is a video, okay, of the video of the level that I showed you. So this is basically the creation screen, and I go back home and I connect to the playing screen, and this is where I am now. And here it's more clear, all the elements, okay, and the interactions that I have assigned. Students are told that this is just an example, so the interactions can be assigned as they wish. It's open to interpretation, and they can even use the different states that the avatar is taking as well, because the avatar changes the states, okay? As you will see now with the pumps here. It gets bigger because it's a power up. So they can also integrate that in the process, which is not in this example, but they are free to be creative actually, and to use it to use the example in another way. Okay, so basically, as a whole, the CameJam provides to these students an informal setting where they can consider this final project from another angle. They have, there is not only peer-to-peer learning, but they also receive comments from other groups, because they will see what kind of level they are doing in the presentation. So, and all this is happening before the delivery of their final project. And the oral exam. So they also receive constructive feedback with the assessment, because there will be one of the teachers will be participating in the CameJam, providing also chemical engineering feedback. And also they will come up with creative ideas by participating, and they can do corrections or even just receive encouraging comments. But also it will help them to train for the oral exam. And they are also actually encouraged to use the levels for the oral exams. So the next step is the analysis of this study 3. I'm basically focused on participants' behaviors, the issues that they are encountering, the intrinsic motivation, usability, and learning. Okay, so what's in brackets number 1, it's because it's happening in session number 1, and in brackets with the 2, it's happening in session number 2. So these are the different methods I'm using. And finally, learning is going to be evaluated by analyzing qualitatively their creations. I'm planning to write a